Now we're going to control in an analog output. So an analog output is different from a digital output, which we've seen already by controlling an LED to be either on or off. So the analog output will allow us to control the intensity of an output. So in this case, we'll use, again, an LED. It will allow us to control the intensity of the LED from 0 to 1, or if you prefer, from 0% to 100% intensity. So for this tutorial, you'll need your Arduino board. You'll need a USB cable. You need a breadboard. You will need an LED, and finally you're going to need just a small resistor. Typically, like a resistor of like 330 ohms or something in that range. Probably no less than 1,000 or 1K ohm is a good choice, and something at least should be at least probably at least 200 ohm. Try to get a 330 ohm resistor. That seems to be a good number. The resistor is going to be used to make sure that we don't that we lower a little bit the electricity that's sent through the LED. Because if we connect the LED directly to if we just send it plug it directly to the 5 volts, then it might overheat and eventually break. So in the past, we've been using an LED without using a resistor by putting it on pin number 13. Now the reason for that, the reason why we were able to do that for pin number 13 is that there is actually a trick, is that there is actually a resistor that is built into the Arduino board just to make it a little bit easy when you get started, and that resistor is only there for pin number 13. So that's the first thing that we'll need, is to have a resistor. And then the other thing that we'll need to do is that we'll need to wire the LED on one of the analog outputs, which are labeled on some boards. They're called PWM, and that stands for pulse width modulation. That's a very technical term. At this point, you don't need to know that much about it. You can read about it online. But basically, these the PWM pins on the Arduino board are the pins that should be used for analog outputs, for variations that are somewhere between 0% and 100%. If you use another pin, then one of those, it's not going to work. You'll only be able to generate either 0 or 1 data. So one example pin that does work, if you look on your board, is pin number 9. So in the code, we'll want to create an analog out object for LED on pin number 9. There's other options. You can look on your board for other pins that would support PWM. Now, the way that you'll want to wire, to create your electronics system is fairly simple. You'll have your pin. I chose pin number 9. And you will have, on the other side, you'll have the ground. And what you'll want to do is to have your little LED here with the long pin, if you remember, which is the positive. And you'll want to have your little resistor somewhere in that system to resist a little bit the current, to preserve that little LED from breaking. So on the code part, if I come back to the code part, I have my analog out LED. This is something that we've seen in the past, And I'll want to be able to control it somehow. So for example, I could say, okay, well, I'm gonna send value 0.5 to that LED. If you upload this, you should see that the LED is like sort of halfway through. It's like 50% intensity. If I send 1 to the LED, it should be 100%. And if I send 0, it should just like switch it off. So of course, between each of these, you need to upload the code. But this gives you a sense of how it works. Like by changing the value that we send to the LED, we control the intensity. Now, how can we make it a bit more interesting by, for example, using one of the oscillator, the oscillator that we've seen in the past? I mean, we've used the square oscillator for controlling digital LEDs, and that should work with that one, but that's a bit like, again, like we'll just be able to have like either 0 or 1, so on or off. What we want is to find something that will, maybe make that LED blink, but in a kind of a more smoother, with smoother variations. So one option is to use one of our analog oscillators like the sine oscillator. So I'm going to create a sine oscillator, and with, I don't know, a period of 1.0. And I'll send that value. I take my oscillator, which generates basically a wave like this between 1 and 0, and send it to the LED. So you can change, of course, the period, and it will impact the LED. Another thing you can do is that you can change that sine oscillator for a triangle oscillator. It's going to be a bit hard to perceive if you do it that way, because the light will just go up and down. So what I suggest if you use the tri-oscillator is to maybe make it a little bit sharper by changing the width. For example, if I set the width of the triangle oscillator to 0, what's going to happen is that I will have a wave that will go a bit like this. So the LED will jump in and then slowly go down. Jump in, slowly go down. If I change the width to 1 here instead, I'll have the opposite. Just slowly raise and then shut down. Slowly raise and then shut down. And finally, I can change, of course, the period. And just so you know, another way that you can control these oscillators as opposed to changing the period is that you can change the frequency. I mean, at the end of the day, it does pretty much the same thing. It's just another way to think about it. So the frequency is, rather than being the cycle, the time until which the oscillator repeats itself, the frequency is kind of like, it's actually 1 over the period. So basically it's how many times per second do I want this to repeat itself. So for example, I could say like 10, so that means like, 10 times per second. That's going to be pretty fast. Or I could say 2 times per second. So when you want to go a bit faster, frequency can be, another way to express what you have in mind. It's just a different tool that you can use. If you don't like it, if you don't want to use it, you don't have to. You can still use the period instead of the frequency.